Guys, good morning, and you are welcome to the part 2 of the time value of money lecture. And in this lecture, our focus will be on annuities. All right, so we are looking at annuity, not annuity factor. Get the difference clear. So we are looking at annuity. And what is an annuity? Annuity actually is an investment package. So let's say your tier 2, your tier 3 that you pay, all right, they are all forms of annuity. Why? Because when you talk of annuity, what should come into your mind is the consistent flow of income. All right, it's not a lump sum. It is a consistent flow of an income. So every period, let's say every month, you put it there 500 cedis, 500 cedis, 500 cedis. So you see that the money that is being there is always 500 cedis. Like it goes like that. It doesn't change. All right, it's 500 Ghana cedis. So annuity is a financial product. So you look at it here. It's a financial product or it's a contract, like an insurance contract that you have done. But what you are going to do is that you are going to provide series of regular payments. All right. So that is what happens. A series of a regular payment. So the payment is consistent. All right. So that is that. And so you put in the same amount. So normally it takes the form of a retirement savings package or any investment package. So personally, so I used to do this EcoBank EDC investment stuff. Every month, my salary goes there straight. So that is how it is. So the consistent flow of an income, and that is what we call what? Annuity. It is an investment product in which you put in equal amount of money on regular basis. All right, that is what we call an annuity. So get it clear, not the annuity factor. All right. In fact, the annuity factor we apply is even a point where the cash flows are the same, and therefore you can use the annuity factor. So when you hear of annuity, what should rather come into your mind is the equal flow of money. So it doesn't change. So it means if it changes, then we are not talking of annuity. All right. So take note of that. All right. And in this annuity, we are going to look at the two forms of annuity. There are actually so many types of annuity. But for exam purposes, we are looking at two. We are looking at ordinary annuity. And I want to even write the A first because A comes before O. And we have annuity due, and we have ordinary annuity. They are all annuities, but the timing of the investment matters. The timing of the payment or the savings matters. When you look at annuity due simply means the cash flow are in advance. So A for A, advance, annuity due for advance. So A, D should let you remember advance, all right? What does it mean in advance? It means that the cash flow that you are depositing, what you are saving as the money investment, is always at the beginning of the year. You see, advance means at the beginning, all right? At the beginning of the year. It means that the cash flows are at the beginning of the year. All right, meaning that if you are saving the equal installment, you save each installment at the end of every installment period. All right, so that is that. Ordinary annuity. So if this one is in advance, then automatically in antithesis, this one will be in arrears. What does it mean in arrears? That means that the cash flow are at the end of the accounting period or the year. It can be year, it can be month, it can be quarterly, all right, so it doesn't matter. All right, so basically that is that. So it is the timing of the deposit or the savings that determines whether it is an annuity due or an ordinary annuity. All right, so take note of that. Annuity due, AD, means advance. All right, so take note of that. That's just a simple way of trying to remember which one is which. All right, so that is fine. But you see, it's an annuity. And if we now want the future value of an annuity, future value or final value of an annuity. So the question is this: if I save 500 cedis every month, into an investment package that has an interest rate which compounds, how much will I get in 5 years' time? Future. I'm doing the savings today, going forward, and I want to know how much I will get in future. So I'm saving 500 cedis every month. And let's say I have insurance policy that says that I have to pay 500 cedis every month. The insurance policy is 5 years. I am paying 500 cedis each month. Each month. All right. And the insurance company says that they will be giving me interest of 10%. I want to know how much money I will get at the end of 5 years. But you see, I am standing here now, and I want to know how much I will get in future. All right. So we use the formula we learned in the part 1 video to actually determine how much we will get. And so the question now becomes, okay, say you said annuity due, ordinary annuity. Which one is this? So you see, the timing of this one matters. Is the 500 cedis that I'm depositing every month, is it at the beginning of the month? Or I'm depositing this 500 cedis at the end of the month? So that is something you always must look out for in the question. Is it the money that I am depositing? Is it at the beginning or it is at the end of the month? So you need to look out for that. All right. So we are going to look at the two scenarios. If this is at the beginning of the month, then which of them are we looking at? Obviously, annuity due. If it is at the end of the month, then obviously we are looking at what? Ordinary annuity. All right, so that is that. And so because it is a consistent flow of an income, we can use a formula. And so in the annuity due, if the payment is at the beginning of every month, then remember the formula we did in the first video? We are going to find the future value. And the future value we are going to find will be given by X, you remember? Then we did another bracket, right? We did 1 plus R raised to the power of what? You remember? N. Okay, so that is what we do. 1 plus R raised to the power N all over what? N minus 1. All right, you remember? Good. So this is what we do all over R. So that is what we did. But here, the issue is that the thing is going to compound. All right, so it is going to compound. So here, remember, here should rather be T, right? This side should be T to represent time. All right, so that is that. So T to represent time. All right, so that is what we learned. Now, what we are now going to do is to bring in the element of the compounding. The element of the compounding. So I think the formula that we use now is bringing in the NT, and here we will also divide this side over N. All right. This one used to be 1 before, even though there is always N there, it should be 1 because why? It compounds a year. But now we are learning the formula in its entirety, and we need to now be careful. So we have brought in the N. The N is here. So what does this formula mean? Now, we said that if we do this formula and the answer we get is at the beginning of the very last year, that is where this answer gives us. So it tells us when it ends. And this is from the part 1 video. You have to continue watching this video from the part 1. All right, don't skip the part 1. So you realize that we learned that the answer this one is giving us is the first day of the last year. All right, so that is that. So we learned that. Okay, and so we also learned that if you want the figure really, so we find out that if this one is going to give us the answer at the first day of the last year, we need to push it 1 year forward. All right, so basically that is what we learned. You need to push it 1 year forward. So we said here, you put T here, and the T is always 1, but the number of times the R is compounding must also show here. So that is how we learned the formula. All right. So this formula that you see now gives you the fact that the person has done the investment at the beginning of the first year, or at the beginning of the year, or the beginning of the period. All right. And the answer that it is giving us is what? At the end of the last year. Now, if you use this formula, because you have said that it is giving you from the beginning of the first year, and it is ending you at the last day of the last year, this formula with this side inclusive is the formula for what we call the annuity due. Annuity due. So take note of that. And it's this formula we learned in the first video. The only thing that has been introduced is the N here, N here, N here, and the N here. So basically that is that. Now, we have a scenario where somebody did the deposit at the very last day of the accounting period. So, or the end of the period. All right. So the deposit is being happening at the end of the period, at the end of the period, at the end of the period. And so what we are going to do now is, if the money is going to be starting at the end of the period, then it means that the formula is still the same. So we want to the final value, and here we will do the same thing. 1 plus R raised to the over N raised to the power NT minus 1 all over R N, like this. All right. So what do you see? What you see here is that this time round, the person is making the payment, this payment, and X that you see, the X that you see is the payment the person is making. So in my example here, it will be the 500, the one that the person is making on a consistent basis. But you see, the formula is the same, nothing has changed. But you realize that this one is being done at the end of the period, end of the period. So it means that if we use this formula, we are short of 1 year. So that is that. Let me draw it, the lines for you, so that you can understand it better, just as we did in the first video. So this is it. So this is year 1, year 2, year 3, year 4, and year 5. All right. And this is the start of year 1. This is the end. So as you can see, there's the start or the beginning. This is the end. So start, end, start, end, start, end, the start, and the end. And we said that if we apply the formula as we see, and the person did the deposit, or he's doing doing all the things, investments, the consistent money at the beginning of each year, then it means that this year he will have an interest that is compounded. So if he did the money here, you see the part 1 video, there was no compound, it was just a lump sum. But this one is doing the money all the time. All right. Now, what happens is that the answer for this formula, like we learned in the part 1 video, this formula, if you do this part, the answer you are getting is going to be where? Yeah, at the beginning of the last period. And so if you want the answer at the end, then it means you need to go 1 year forward. So going 1 year forward again to the end of this here, this point here, is the reason why we add this bit to it. Now, if somebody does the investment here, it means that the same formula gives him the answer here. So you should spot the two. if we did it here, this formula will give us the answer here. This one that you see will give us the answer at here, and it was proven in the part 1 video. So if we do it here, and we will be here, all right, and we want the answer here at the end of this period, we need to go 1 year forward. So we do a 1 year future value. So that is that 1 plus r raised to the power t. The t is 1 year. All right, but if we do the investment here, and we are still doing using 5 years, 1, 2, 3, 4, 5, then it means that it can be the same, because this one, this year, he did it at the end, so this one will be out. So the answer gives us straight to this point instead of this point. All right, so that is the distinction you need to understand. That is why the money payment is, one is at the beginning and one is at all the end. All right, so basically that is that. Let's define the variables in the formula, which you know from the part 1 video. So X, you see, is the annual or the equal payment. So the series of equal payment, the series of equal amount. Maybe it can be receiving, but it's an investment. You rather put in there. So the series of the equal amount. So in this case of my example, the 500 cedis each month. All right. So I'm depositing the money each month. So the question has to tell us that how many times is this percentage compounding? Let's say it is also compounding each month. That means that is 12 months in a year, right? So that is that. So if it is compounding monthly, that is 12 times in a year. All right, so that is that. Now, so in that case, that is X is the series of equal payment. 1 means 1. Rate, do you remember we learned the rate? Which type of rate is that? Since this one is compounding monthly, the X we are looking for, the R we are looking for is which one? The effective one. So the effective rate. If it is compounding once a year, we can use the nominal. All right, so that is that. Get the difference between the two. All right, so R, we've defined R. What is N? The number of times it is compounding in a year. So in a monthly, if it is monthly, there are 12 months in a year. So it will be compounding 12 months. So number of times of compounding in a year. That part is very important. In a year. Then what is T? T is the time for the investment. So in this case, I have 5 years. So if I want to do this thing in these two cases, what will happen is that in the first formula of annuity due, the future value, which is the 5 years time, I'll find it by doing X equal installment. Let's learn repeatedly the formula 1 plus R N T minus 1 all over R N. And because of where the answer will be giving me, I have to do additional what? 1 plus R over N raised to the power T. So that is that. So if I am putting these things in my formula, the money that I'll be paying is 500 cedis every month. I have here 1 plus R. R is 10%, so 1 plus 0.1. The 0.1 will be divided by 12 because it is compounding like that. All right. Then here, 12 multiplied by the 5 years. All right. So all minus 1. Then what do I do? All over R again, 0.1 over what? The number of times it is compounding. So that is that. And when I get this thing, I'm going to go further forward. All right, I'm going to go further forward. So how many times the thing is compounding? So you see here, the frequency of the payment. Frequency of the payment, that is the frequency, the number of times the thing is compounding. So I'll have 1.01. It will be compounding 12 times in that period. And my T is just 1. So basically, that is that. So that is how you go by it. The rest is the formula that you work out. All right. So if you want to work out this, let's work out the using our calculator. Let me show you. You can punch everything on your calculator once, but you can decide to use the old school where you do this part, you keep the number, then you continue from there. All right, so let's see how we punch this on our calculators. All right. All right, so guys, let's work this thing out. So 0.1 divided by 12. This one will give you something like 0.00083 continuously. So what I'm going to do is that I'm going to work it out like this. So when I punch 1/12, 0.1 over 12, that figure that I get, I'm going to keep it. Then I'll punch this side, the top side. So that will be, the top side will be 1 plus 0.1. All right. And that 0.1 part, or I'm going to, the answer that I had before, 0.1. All right, 0.1 over 12. The answer that I had before, which is 1 over 120, is basically this thing that I've done. So I will do plus 1. All right, so you can do it like that, plus 1, so that you've done the 1 in the bracket here. Then you look at this one. Even though I know that 12 times 5 is 60, I'll do it raised to the power 5 times 12. So you point the raised to the power 5 times 12 like this. All right. Okay, so you do that. Then you punch your answer. Then minus 1. So it means that you have done the top part of this equation. Then you divide everything by 0.1. So you divide it by, you can use this sign here, divided by, so you have 0.1 over 12. All right, 0.1 over 12. So that is what I have done. Now, when I punch my answer, it is giving me 77.43. Then I multiply it by 500. So that gives me a 38,718.54. Then I multiply the whole thing by this side. All right, so that is it. So this is a plus, right? There's a plus here. All right, so the same thing we went through to do. So you have this one, you've written it down. You are just doing it for this side. So the same thing you did for the top here, that is that. So you had 0.1 divided by 12 plus 1. All right, it's raised to the power 1, so it's the number itself. So that one gives me something like 1.00833333. If I multiply by 38,718.54, what I get is 39,041.19. So that would be my answer. So if you save 500 Ghana cedis every month with a 10% compounding interest monthly, 5 years time, you are going to get 39,041 cedis, 19 pesos. So that is how you go by it. Now, with the same formula, assuming you were doing it for the annuity due, the only thing is that this part of the equation will not happen, and your final answer would have been this one. All right, so basically, that is that. So that's all. Now, what we are going to do is we are going to pick up this question, and I'll solve this question with you. Then I'll show you what a sinking fund is. Then we end the class. Part 3 will be done to look at these questions, and we will zoom into the past questions. All right, so basically that is that. So let's look at this question. You can do this on your own. because it's very easy, like the 500,000, 500 cities example that I have done. So you look at the savings, you are investing 100,000 per annum. So this one, it means it's compounding once a year for 4 years. So that is your 4. Then it is on the last day of the year, which means it's what? Ordinary annuity. So that is it. Very easy. All right. So that is that. So you repeat the formula and that will be all. All right. So that is how you do an annuity for the future value of an annuity. Now let's look at the present value of an annuity. So the present value of an annuity is the same. You will need X, all right? You need X, but you do 1 minus 1 over 1 plus R raised to the power T all over R. All right, so that is the formula. But because the thing will be compounding, you have to bring N here, and here. So basically that is that. This is the present value of an annuity. X is the equal amount of payment. Then so this one, you are looking for the present value. So this one means that PVA, which is the present value of an annuity, is the present value of all payments. So what is the present value of this payment as you will be making it? So the frequency of the payment, PMT, the amount that you are paying equally. You see, the difference between this formula and the other formula is that in this formula, you are looking at the future value. Then in this formula, you are looking at the present value. So the thing is that you want to know. So you borrowed, let's say you want to know if you'll be saving an amount on equal installment for a future year, or let's say you know the future amount, but you want to do the present value of this future amount, then it means you are going to use this formula. Present value of the future amount. You are going to use this formula. So if you borrow the money now, your borrowed money now is present. All right. So these words means present. Now, today, currently, real. All right. These words or immediately. These words means or year zero. They all means present value. They mean present. All right. So it means that what if you save an amount, you want to know the present value. Normally, this thing is supposed to help you know the future value, but you want to know the present value of that future value, then it means this is what you are. All right, so that is that. So in this formula, the future value should be known. You are not the one finding the future value. So take note of that. All right. Now, the last thing you should know is that you see in this formula, there is a PVA, there is X. Also in these formulas, there are X's. Now, what is that X? We said the X is the equal installment that you'll be doing. All right. Now, sometimes you may be given the PVA, you will have to find the X. So it's the same formula, you make X the subject. You don't need to do the change of subject of the formula, but you just insert in the figures. All right, so basically that is that. Okay, so that is it. So, and that part is what we call a sinking fund. X denotes sinking fund. All right, the money that you'll be putting into a fund equally. So the equal money. A sinking fund is just a fund that you open to put money in, like a series of money in to pay a future debt, like the way we do in Ghana. So if the question asks you how much should be in the sinking fund, all right, equally, how much should you equally put in the sinking fund so that you'll be able to pay a debt in future? Then it is the series of equal installments, which is the X. All right. So if the government has borrowed some money and will be paying in future, so future, and the government wants to know how much money he should be putting aside every month to be able to pay that debt in future, then it means you are looking for X. All right. So take note of that. So the question that I'm going to do with you will be this question 9, 8, and 9. Then we can call it a day. So we will meet another time for the part 3. All right, so look at this. That the limited will have to pay. So will have to pay is a statement of future. All right, will have to pay 5 million. So in 5 years' time, he will pay 5 million. So the 5 million in 5 years. So that is that. It's a 5 million in 5 years. So the 5 million you will be paying, will have to pay means that you will be paying this 5 million in future time. And the company wishes to save up some money so that when it gets into that future, they'll be able to pay. The account they are paying the money into pays an interest of 8%. And it says that the payments are to be made at the end of each year. All right, at the end of each year. When it comes to the present value, whether at the end of each year or at the beginning of each year, it doesn't matter. But how will you know it's a present value, or how will you know it's a future value? So that is the first thing you need to answer. So it says that what fixed amounts must be set aside for 30 to save 5 million. So this is a question you must ask yourself. Now, he will have to pay 5 million. He just wants to know the amount he should be saving. Will have to pay 5 million is a futuristic statement. So the 5 million is a future value in 5 years' time. So that is that. So the step to answer a time value of money question is step 1. Find out which formula to use. Is it a future value? Is it a future FVA? And which of the FVAs? Is it annuity due or ordinary? Or is it PVA, present value of an annuity? So that is your first step to do. So if you now find it, then you put the figures into the formulas. So basically that is that. So if you look at this particular question, this 5 million is a future figure. All right. So, and he's doing it at the end. End means what? Ordinary. So that is that. So all you need to do is to quote your formula X 1 plus R over N, NT minus 1 all over Rn. But it is at the end, so it ends here, ordinary annuity. But what are we looking for? The question says that the payment to be made at the end of each period. So it says what fixed amount should be set aside to be able to save up to that 5 million. We already know that this side is 5 million, but it is the X we don't know. Now we come in here, we put in 1 plus 8, 0.8. It is compounding how many times? Once. So it's as good as saying 1 plus 0.8. 1 multiplied by 5 years, all minus 1, to bracket 0.8 over 1. That's it. So this one is quite easy. So when you do these things together, you have 1.8 raised to the power 5. All right, minus 1. All right, divided by 0.8. So what I am getting is, I'm getting 5 million is equal to 223696x. That is that. All right, that is the figure that I'm getting. So you can also try it at your end. It looks as if this one is quite different. Little different. Yeah. So if I take my 5 million and I divide it, I think it's a little different. So we have 1.08 raised to the power 5 minus 1 all over. Okay, so it's 8%, meaning it's supposed to be 0.08, not 0.8. 0.08. So it's 1.08 raised to the power 5, which gives me 1.49 blah 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 minus 1 all over 0.08. So it's actually a figure that you get here It's actually 4 point, yeah. So 5 million is equal to what I have here is 5 points rather 5.866, something like that. So if I now divide X, right? Yeah. If I now divide this side, so this one should be 0.8x. If I now divide it, so I'm getting something like 8,522. Yeah, so that is that. So the final answer, this number can continue. The final answer I'm having is 852. My own is 282. All right, so you can figure it out here to also see a small difference, which may be due to approximations. All right, so that is that. Yeah, 282.28. All right, so you can try it at your end to see you get the same figure. All right, so that is that. So last, then we go. This one is saying if YSN wants to invest in an equal installment. All right, so we will pick up with this question. If YSN wants to invest in an equal installment for 5 years in a bank for 5 years, starting from January 2021, in order to have the following money available. So she wants to save an amount, equal installment. We don't know the amount yet. An amount of equal installment. So an equal amount. And that equal amount, we don't know yet. We don't know. And she wants to save it for 5 years. So that by the time 5 years will come, she will have 1 million in order to have the following amount available. 1 million for the purchase of a land. And the land, she is buying it in 2026, January 1. So the investment that she wants to do is in 1st January 2021. So 2022, 2023, 2024, 2025, 2026. That's 5 years. Not only that, she wants to also have enough money to buy an annuity, an investment package. So of 240 per annum for 4 years. So we have the annuity, which is the investment package, and she wants to buy that one for 240,000 per annum for 4 years, commencing from January 1, 2027. 1 year ahead of this. So that is the problem that we have to solve. And that 4 year, the interest rate is 8%. It says that how much will if one need to deposit at the end of each year in a fund to generate a 10% annual compounding annually. So that is the issue. So we need to know how much you should be saving. The question is this thing a present value? Is it future value, and which of the future value? The question already said it is at the end. So if it is a future value, then we are looking at what? Ordinary. So basically that is that. And now, thinking about it, we want some money to have in future time. Now it is this date. We want these monies at future time. This one and this one. But unfortunately, this figure will start in 2027. So it means we need to bring back this figure to 2026 so that we can have the total figure in 2026, or we need to push this 1 million also to 2027 so that instead of 5 years, everything will be 6 years. So that is the trick inside there. But it is better to push this one back to 2026 so that we can do everything within 5 years. So if I want to push this figure per annum of this figure back to 2026, we are going to apply what do we call it? Present value. Because this one, when we stand in 2026 January 2026, 2027 is in its future. So we will do a present value of this money, this 240 that is we are looking at. And it is an equal payment. So he's going to do it per annum for 4 years, equal payment for 4 years. And so when we are PVing it back, we are going to use, it's either you do 240, 240, 240. It's either you go this way. Year 1, 240,000. Year 2, 240,000. Year 3, 240,000. Year 4, 240,000. And you apply the discount factor of 8%. All right, then you PV them too. So if you want, let's do it like that. Let's go and see if we have 8% in the discount factor table. Then we will use it to do the PVing of it. Let's go and see. Do we have 8% discount factor? So 8%. So for 8% for 4 years, 8% year 1 is 0.926, year 2 0.857, year 3 0.9794, then we have year 4 0.735. So you can do that, but like I always say, if this figure is already the same, we can as well do 240,000 multiplied by annuity factor of 8% 4 years. So where is that one to? 8% 4 years, which is 3.312. All right, so you can do any of them. You will still get your answer correctly. All right, so here we are back here. All right, so if you use this formula, what are you getting? 240 by 0.926. So I have 240. 240 by 0.857. I have 205,680. 240 by 794. I have 190,560. Then 240 by 735. I have 176,400. So if I add it, 190.56 plus 205.68 plus 222.24. That gives me a figure of the total 794,880. Or if I also use this shortcut, it will be just 3.312 by 240. The same answer, 794,880. So all these figures that I've had is giving me my figure at 2026, sorry. So it means that in 2026, January, I have the land value, which is 1 million. Then the annuity value also at 2026, which is 794,880. So in total, IFWA is looking at having 1,794,880. in 5 years time. So the future value now is, you remember your formula is equal to x 1 plus r n nt minus 1 r over n. So the future value now is that, and it's at the end, so it is ordinary. I didn't mean it's at the beginning. We would have added another one. So now we know our future value is 1794. And you see, we told you that this formula, if it is ordinary, if it is giving you this formula, then the value that you are going to have is at the end of what? Year 5. But you see, the question now said if one wants the money at the beginning of that year. So it means when we get our final answer, we still have to PV it back to the beginning. So we have 1794,880 is equal to x, what we are looking for. Then we have 1 point, the rate that was given us. What was the rate? 10%. So 1 plus 0.1 raised to the power 1 is compounding annually. So 1 by 5 years. So that is what we have. All minus 1 all over 0.1 over 1. So that is that. So let's do, so I have 1794,880. So this one will be 1.1. All right, raised to the power 5 minus 1 all over 0.1. I have 6.1051 x. So I say 1794,880 divided by answer. So what I'm having here, x is equal to 293,996.82. So that is the answer. But like I said, this one is giving us the value at the end of year 5. But they said if one wants the money at the end, beginning of January, the first day. And if this one is the end, then it means I need to PV this figure. All right, how do you do present value? It is the future value multiplied by 1 over 1 plus r raised to the power t, right? Or n, you can use n, but here the n will mean that the number of years, not the number of time the thing is compounding. So just to be safe, let's just use 1 over 1 plus r raised to the power t. So the future value as far as January 2026 is concerned, January 1, 2026 is concerned, it is 293,996.82 multiplied by 1 over. So we can go back and read the discount factor for 10%. It's 1.1 raised to the power 1. And if we go back and read it, what will we get? So that is what you see here. So it means that I'm multiplying this by 1 over 1.1. Any number raised to the power itself, divided by 1 or raised to the power 1 is the number itself. So my final answer is 267,269.84. All right, so basically that is that. It's not difficult, just follow the issues or the procedures one by one. So the tutor advice that I have here is that says that this area is very tricky. So you have to make sure that you take your time, you analyze this sentence, then you should use the illustrations that we have here as a guide. All right, so you take your time step by step. All right, so video 3 will look at solving all the questions that you have here. All right, so take your time with it and you'll be fine. So thank you very much. See you in the part 3.